So we're going to work on greatest common factors. So I'm gonna take 4 minus 6a. And basically what you do is you think of the prime factorization. And this has an a, so we just tack on the a down here. Now, what do these have in common? Just the 2. That's it. Just 1, 2. So our greatest common factor for that one is just 2. Okay? Let's consider 2a squared plus 8a. Well, 2a squared, this is just going to be 2 times 1 times a times a. 8, on the other hand, is 4 times 2 times a, and then 2 times 2 times 2 times a. So on this one, I have 1, 2. That's what they have in common, and they both share an a in common. So the greatest common factor that they have is 2a. So far, so good. Next one. 12a squared minus 8a. 12 is 4 times 3. A squared is a times a. 4 is 2 times 2. 3 is a prime number. 3 times a times a. 8, and it's a negative 8, so I'm completely ignoring the negative signs for now. That's going to be 4 times 2, and then we tack on the a. 4 is 2 times 2 times 2 times a. Now for this one, I have a 2 and I have a 2, but I also have another 2 and another 2, and then I have an a and I have an a. So the greatest common factor is 2 times 2 times a, or 4a. Does that make sense? Lastly, I have 4a plus 8a. 4 breaks down into 2 times 2. The a is just by itself, so that's a. 8 breaks down into 4 times 2, and then 4 breaks down into 2 times 2 times 2. So then my greatest common factor is 2 and 2, another 2, and another 2. So that one is just 2 times 2. Whoops, something went wonky there. 2 times 2, which is 4. And that's the greatest common factor. Okay. Now, in all those, I kind of glossed over that, and I probably shouldn't have glossed over it, but I want to point out that in all those scenarios, I focused on prime factorization. Now, prime factorization is based on breaking down a number until you have only prime numbers. What are those prime numbers? Well, there's 2, 3, 5, 7, 11, 13, 17, 19. It goes on and on and on. Why are they prime numbers? Because the only way that I could get 2 is I have to multiply 2 times 1. It's the only way I can get 2. 3 is 3 times 1. 5, the only way I can get that number is to multiply 5 times 1. 7, the only way I could get that number is 7 times 1. 11, same thing. 11 times 1. That's the definition of a prime number. It's not a composite. 13, the only way I can get 13 is 1. Okay, so all those numbers, and they go on forever. So usually we tend to only need to go about this far. Very rarely do we go higher than those numbers. And most of the time we're focused on the first 3. Okay? Every once in a while you'll get a 7 or an 11 or something like that, but most of them will break down to 2s and 3s, 5s. Okay? Any questions? Okay. So that's example number 10.